Here we have the homework that goes along with the targets 6 and 7 lesson. So we're factoring cubics by grouping, and then we're going to be factoring quartics in quadratic form. Okay, so let's see, let's look at number 1. From target 6, we're going to be factoring and solving cubics. So because we already have it in 4 terms, it looks very convenient for us to factor by grouping, so that's exactly what we're going to do. We're going to group the first 2, group the second 2, and then factor out GCFs from both of those groups. From the first group, I can factor out an x squared. What I'm left with when I divide both of those terms in the front by x squared is x plus 3. And then because my leading term in the second group is negative, I'm also going to factor out a negative in addition to whatever number I factor out. In this case, I can factor a 5 out. 5 goes into 5 and 15. I'm left with x plus 3. And oh look, if you notice, x plus 3 and x plus 3 are the same thing. So I'm pretty much done at this point. I can rewrite this as 2 separate factors and then solve. One of them is x squared minus 5. One of them is x plus 3. So x squared minus 5 equals 0. I'm going to add 5 to both sides. And I get x squared equals 5. And then when I take the square root of both sides, I have to, oops, drop my pen. That was loud. I get x equals plus or minus root 5. And I cannot simplify root 5. It's just got to be left as root 5. When I solve for this one, a little simpler. I just subtract 3 from both sides, and I get x equals negative 3. All right, for number 2, let's see. Same thing. I'm going to look at the first 2 terms and then the second 2 terms. The first group, I can factor out an x squared again, just like in number 1, and I'm left with x plus 2. And then out of the second, I can just factor a positive 3 out, so I'm going to put plus 3. If you ever factor out a positive number, please put the plus sign, because it will remind you when you get to the next step to do x squared plus 3 as one of your factors. And I'm left with x plus 2 here. And oh look, once again, x plus 2, x plus 2. We have succeeded. So I'm going to rewrite this as the 2 factors like we are used to. One of them is going to come from the things we factored out. So x squared plus 3. The other comes from the green check mark since in parentheses. So x plus 2. Now I can solve. X squared plus 3 equals 0. I subtract 3 from both sides. I get x squared equals negative 3. And then I take the square root of both sides. I end up getting x equals plus or minus I root 3. You cannot forget the I. You cannot forget the plus or minus. And then root 3 can't be simplified, so I just leave it as root 3. X plus 2 equals 0. I'm just going to subtract 2 from both sides to get negative 2 is my answer. All right. Let's move on to number 3 and 4. Same thing here. I'm going to group these. Let's see what I can factor out. From 3x cubed plus x squared, I can't factor a 3 out because there's not a 3 in the second term, but I can factor 2 x's out, so x squared. And then what am I left with? I'm actually left with a 3x plus 1. When I take an x squared out of itself, I have to be left with 1. And then my leading term in the second group is negative, so I'm going to factor out a minus 1, actually. I can't factor any number or variable out, so I'm just going to put a 1. I'm left with 3x plus 1, because I make both those the opposite sign when I factor a negative 1 out. And look, 3x plus 1, 3x plus 1. I did it right. So I'm going to go ahead and move down here, rewrite these. I have x squared minus 1, 3x plus 1. And if you notice, oops, this is difference of squares. So it's going to turn into x plus 1, x minus 1, and then I still have that 3x plus 1. Don't forget difference of squares. Please be able to notice that. It's two perfect squares separated by a minus sign. When I factor these, x plus 1 equals 0. I'm just going to subtract 1 from both sides. I get x equals negative 1. X equals positive 1. And then I have to do a couple things here. Subtract 1 over, and I'll divide by 3. So dividing by 3, I get x equals negative 1/3 actually. Those are my three answers. Let's look at number 4. I'm going to group like that. And what can I take out of the first group? Well, I can't take out a number. 3 does not go into 5. I can't take out a 2 because they're both odd numbers. So the only thing I can factor out here is an x squared. I'm left with 3x plus 5. And then out of the second group, I can factor out, well, I can factor a 4 out. So plus 4, and I'm left with 3x plus 5 as well. So once again, I did it correctly. 3x plus 5, 3x plus 5. So I can just turn this in to x squared plus 4, 3x plus 5. Do not think that x squared plus 4 is difference of squares, because it is not. Yes, x squared and 4 are both perfect squares, but difference of squares means we need a minus sign in between those two. We actually have a plus sign. So I can't do difference of squares here. I just have to solve like normal. X squared plus 4 equals 0. I subtract 4 from both sides, and I get x squared equals negative 4. Then when I take the square root, I'm actually going to get imaginary numbers. So when I get x equals plus or minus 2i. Now, if you left this as plus or minus I root 4, you might get maybe a half point off because you didn't recognize that root 4 is 2. But you could go farther from there and say that root 4 is 2. Just please, know your perfect squares. It makes it easier on you. And then 3x plus 5, let's set that equal to 0 as well. Subtract 5 from both sides. 3x equals negative 5, and I divide by 3. So x equals negative 5/3. Oops, okay. There we go. Couple multiple choice down here. Let's look at the first one. I'm going to have to erase just a little bit here so I can see better. Alright. If you need to see what that was, you can just rewind the video and go back up to where I was doing that problem. Alright, just like normal, factoring out. What can I factor out of the first? I'm going to do this work down here, actually. I can factor 5x squared, actually. It's a lot out of the first one. I'm left with 5x minus 1. And then I can factor out a 2 from the second group. Now, don't forget that leading term, that negative 10x, is a negative. So I'm going to factor out a negative something. It is going to be a negative 2. I'm left with positive 5x plus, minus 1. So sorry. When I factor out a negative 2 from negative 2, I'm left with 1. So plus 1. Alright, there we go. So let's see. Oops, did I do that wrong? Oh yeah, I'm sorry. When I factor out a negative 2 from positive 2, I get that negative 1. Sorry, I was looking at the answers, not the question. When I factor out a negative 2 from positive 2, I get negative 1. Alright, now I can rewrite this in my two sets of parentheses. I have 5x squared minus 2, and then 5x minus 1, because these were the same, so I ended up doing it correctly. So is there anything that looks like that? This has a 7 in it. I don't know where that came from. This has a 3 in it. And then this also has a 3 in it. So the answer here is C. It's in a different order, but multiplication doesn't matter, so you can put that in any order. 5x minus 1 times 5x squared minus 2. Still means the same thing. And then number 6. Let's group together here, group here. I can factor out a 3 x squared out of the first group, and I'm left with 3x plus 5, and then I need to factor out a negative something from the second group because that leading 3 is negative. I can factor out a negative 1, actually. It's the only thing I can factor out. And I'm left with everything changing sign. So positive 3x plus 5. And then, 3x plus 5, 3x plus 5. I can go ahead and rewrite this. 3x squared minus 1, 3x plus 5. No, this one has a 4. I did not factor out a GCF, so no. So C is the answer here again. 3x plus 5, 3x squared minus 1. All right. Let's look at the back of that homework. Target 7. I can factor and solve a quartic in quadratic form. So I think there's just 4 of these. Yep. Let's see. My A value here is 1, which is really nice. So I can basically say what times what will give me negative 15. What plus what will give me 2. So I'm going to look at the factors of 15. 15 and 1, 5 and 3. The only thing logical that's going to work here is 5 and 3. I'm trying to get a positive 2 and a negative 15 when I multiply. So one of these has to be negative. And for it to make sense with the addition, 5 plus a negative 3 or 5 minus 3 will get me 2. So positive 5 and a negative 3. So when I move down here to this step, don't forget this has to be m squared. I'm going to do plus 5 and minus 3. Now I'll go ahead and move on to solving. M squared plus 5 equals 0. I subtract 5 from both sides. I get m squared equals negative 5, and then I take the square root of both sides to get me m equals plus or minus I root 5. Don't forget the I, don't forget the plus or minus. You can't simplify root 5, so we're just going to leave it as root 5. M squared minus 3 equals 0. I'm going to add 3 to both sides. I get m squared equals 3, and then I take the square root of both sides. M equals plus or minus root 3. Just leave it as root 3. Let's look at number 8. X to the 4th plus 9x squared plus 20. Same process here. We're going to just use the A is 1 method. So let's see. What plus, I guess I can do that. What plus what is going to give me 9. What plus what's going to give me 20. I did it in the wrong order, but it's whatever. So factors of 20. Let's see, we have 20 and 1, 5 and 4, 10 and 2. 5 and 4 is going to work the best here. Everything positive, so 5 plus 4, and then 5 times 4 to give me 20. Alright, so I can just kind of move down here to this part. Let's see, I have x squared plus 5 plus 4. And then I can solve. Let's do purple. X squared plus 5 equals 0. 5 from both sides, I get x squared equals negative 5. I take the square root of both sides. X equals plus or minus I root 5. And then over here, x squared plus 4 equals 0. Subtract 4 from both sides. I get x squared equals negative 4. And then I take the square root of both sides. X equals plus or minus 2i is actually the answer there. Because 4 is a perfect square. When I take that negative out of the square root, I'm left with the root 4, which is 2. Plus or minus always. Very last 2 problems. Let's look at 9. My A value is still 1. These are pretty simple, actually. So what times what is going to give me 12? And then what plus what is going to give me 7. Let's see. Factors of 12. We have 12 and 1, 6 and 2, 3 and 4. Ooh, 3 and 4 is going to work. Everything positive. 3 plus 4 will give me 7. And then 3 times 4 will give me 12. So I'm going to skip down here to this step. I have x squared here, x squared here, plus 3 plus 4. All right. Let's solve these. X squared plus 3 equals 0. Subtract 3 from both sides. X squared equals negative 3. Square root of both sides. I get x equals plus or minus I root 3. And then x squared plus 4 equals 0. X squared equals negative 4. I get x equals plus or minus 2i. Don't forget the I, don't forget the plus or minus. For example, I'm just going to throw this out there. If I were to be left with x squared minus 4 as an answer, I would have to bring this down, change it to x plus 2, x minus 2, and show that in my factoring to get full credit. So just in case that were to come up in a question on a quiz or test, you would have to show me that step, okay? So all of these in the back of the homework are pretty simple, but they might get a little harder as we go on. So yeah, just letting you know that if you did come across that, you would have to do difference of squares there. Let's do number 10. So a value is still 1. So what times what will give us 10? What plus what will give me 7? Factors of 10, I have 10 and 1, and then 5 and 2. Well, 10 and 1 is not going to work, so 5 and 2 has to work. So this turns into a squared, don't forget that, plus 5 plus 2. So when I solve, a squared plus 5 equals 0. Subtract 5 from both sides. I get a squared equals negative 5. And then I have to take the square root of both sides. So a equals plus or minus I root 5. It's kind of been a common answer. I've seen that plus or minus I root 5 a lot. And then a squared plus 2 equals 0. I subtract 2. I get a squared equals negative 2. And then I take the square root one more time to get a equals plus or minus. Oops, I even messed up. On the very last one I messed up. Plus or minus I root 2. There we go. Alright, so the back of the homework was pretty simple with the a equals 1 with all these factorings, but don't forget in orange right here on the left that if I were to be left with x squared minus 4 or x squared minus 1 or x squared minus 9, that I would have to change that to x plus 2, x minus 2, or x plus 1, x minus 1, or x plus 3, x minus 3. I would have to recognize that was difference of squares and to factor accordingly to get full credit there. All right, and that's the homework. If you have any questions, don't hesitate to ask your teacher or any of the Algebra 2 teachers.